So first of all, English measurements, not so nice. With a lot of those measurements, some of you know, based on size, as Eddie was saying, when you should multiply or divide. I highly recommend, and so does the book, and so do your science teachers, that you start working on this thing called a unit fraction. It might not be necessary here. It really, really helps if you start practicing on the one-step ones. And I was trying to show you that, but it didn't come through very well today. That when you were converting years into seconds, or my sister's doing cubic meters per second into drops per minute for IVs, she wants to be nice and consistent. There's a reason to learn unit fractions. This might not be good examples. I'm not going to ask anything harder than these. All right? These are kind of the samples that we're looking at. And the idea is the units, that 12 inches equals 1 foot, if I were to write it as a fraction because they're the same, that's just the number 1. That's why they're called unit fractions. That the numerator and denominator are the same. 12 inches divided by 1 foot is just 1. 1 foot divided by 12 inches is just 1. I don't think about it at that level. What I think about on this, if I want to convert 65 inches, you're trying to do something with 65, and so I write down my beginning value. And if I want to convert 3.4 feet, same thing, I'm going to write down my beginning value. This fraction represents multiplying by 12, and this fraction represents dividing by 12. The reason I think you know this, it's just stressed today. If I have 12 in the numerator, I'm multiplying. And if I have 12 in the denominator below 1, I'm dividing. Alright, so this would be dividing by 12, and that would be multiplying by 12. And the thing with the unit fractions is if I screw up accidentally, damn it, I screwed up, I'll know it. How do I know I screwed up on that? I can't cross cancel. So I get this visual on whether things went good or bad. That one was an oops, and I got to try again. And I try just the reciprocal or the flipped, and I feel pretty good this time because they cross cancel. On this example, I want to divide by 12. And so 65 divided by 12. And what I try to do on exams when they're calculator is give you a rounding digit. On these examples, I don't always know that they're going to need to be rounded. So let's say the tenths place on that one. Did I type it in right? Yeah.
No, you're fine. Yeah, I said 5 feet 5 inches because you don't 5.
Yeah, that's a different conversation entirely. I want you to just say 5.4. Or the hundredths, it didn't say. And Darryl changed the 0.5 inches. That's the conversation for a different day. And 3.4 feet, I want to make a decision about which unit fraction to put there. What do I want to have cancel? Feet. So I put 12 inches over 1 foot to get the feet to cancel. So you can see a whole bunch more examples like this in the book, but I'd like you to work on doing it with unit fractions. So do these conversions with unit fractions, even if they seem like they make the one-steppers a little harder. And so 3.4 times 12. It might help some of you, maybe this is the issue, if you make the whole number into fractions so you can see the multiply across. And if that helps you, I made the original into a fraction to help me see it. That's 40.8 inches. And as I shown earlier with the metrics, you can totally use the unit fractions. And in that little handout that you'll get on the final, it even provides a bunch of the unit fraction information. Yeah, I don't know. But I would find it easier to use this stuff, which will also be provided. So, now Jackson.
Begin at your starting unit, move to your starting unit, and then move to your goal unit.
Begin at your starting unit, move to your goal unit. The decimal moves to the same number of places. That's what you're trying to, I was just trying to see what to translate. Yeah, so that's supposed to say begin at your starting unit, move to your goal unit, the decimal moves the same number of places. And so I tried to explain, but didn't very well, that meters, liters, and grams are just symmetric across these. They change which letters there. And so it's really, maybe I should redo this thing and put all three versions there, but I'm not going to, because I'd like you to know this, that they're symmetric. And so if I'm asked to convert $437.4 centimeters to meters, I start at my starting unit and I move to my goal. Where's my goal at?
To the left.
I move. So start. Which way am I moving?
The left.
I move to the left 2 places. Which is, yeah, it's my handwriting more than your writing. So the reason to write them from big to small, which isn't normally how we would do something like this, is so that your move is precisely the same way. When I learned it, we wrote them the order that you would expect, and I had to do this little flip-flop of it was always the opposite order, so I did get it mixed up when I first learned this. I think this is the way to go. I like the book's consistency. If you write this, now mind you, you can ignore the word memorize wherever it said it, because I'm giving it to you. But in a science class, you may not be so lucky. So in a science class, you'd work on memorizing that. So that's all I'm going to talk, unfortunately, about 5, 3, and 5, 4. But on Wednesday, bring your homework. I'll answer questions. All right, hopefully I'll remember to spell this out a little better next time. I haven't taught this in a while. I hardly ever, out of the old book, got enough time to teach it, but I think it's an important section. So, I have taught, on the other hand, percents a whole bunch. Does anybody know what percent means?
Times by 100 or numbers that goes into parts per 100, or how does it go?
Any of these? I'm hearing lots of good ones. Parts per 100, out of 100, that kind of statement. Right. I'm not a big fan of actually teaching these as rules. I would much rather you could walk through these pictures and change all those between fractions and percents and do them as pictures or using the understanding. But if that was a struggle on any of those, okay, I'm going to give you a set of rules, which is another way to go around it. I use the pictures. So in my head, I picture a decimal square. But as a rule, to change a percent to a decimal, you move the decimal point how many places? It's always going to be about 2. The word percent or 100. Move the decimal point 2 places to the right. For example, 3.5%, to change a percent to a decimal 2 places to the, again, I think of the pictures, not the rule personally, but as soon as I thought this through, I was like, oh, that's the wrong way. So 3.5%, if I want to make it a decimal, which way do I move the decimal? It's to the left. So starting as a percent, it's going to go over a couple of places to the left. So it's 35 hundredths as a decimal. Now, I, in my head still, think about it as 3.5, and I picture, okay, if I want that as a decimal, it's about 35 thousandths, because it's about... That's your rule. Does that make sense? 2 places to the left. Okay, that's what we were doing when we filled in. If you look back at each of those that we filled in, we started with the percent. We went 2 places to the left on every single one of them to get the decimal, including this kind of difficult one of 0.5% becomes 0.005. Now sometimes they'll give you the decimal. I want you to go back the other way. So we're going to move 2 places to the right, the vice versa kind of thing. So for example, if next week we're working a problem and we come out with an answer at 0.042, otherwise set as 42 thousandths, and they wanted the answer to be in percents because we communicate in percents so often, as we'll find out on Wednesday. You could think about it as going this way, 2 places. Another way to think through these same 2 things, to change a percent to a decimal, you could think about as dividing by 100 and changing a decimal to a percent, you could think about as multiplying it by 100. Okay. Just try not to move the decimal the wrong way. And I just think with experience, 3.5% is close to that. If you move it the wrong way, you're going to end up with 3,500 as your decimal doesn't sound quite right, so you can back check yourself. Okay. These two ideas are the most helpful for the difficult part, which is the fraction stuff. So it's a good idea to be able to write percents, fractions, vice versa, back and forth. My notes here, and I was gonna do so yeah, and I'm sorry I'm giving straight out lectures so much today. Kind of when you get behind, it's one way to catch up a little bit. But I think that it's okay to lecture quickly through these. You'll get them with practice. When we get to the applications on Wednesday, you'll be doing a lot more problems. I'll show you something you try. I'll show you try. But here, these are the fundamentals. So if I want to write a percent as a fraction, I divide by 100. For most examples, such as changing 3% to a fraction, you can just think about putting 100 in the denominator. Okay, so for standard examples, that's like putting a denominator of 100. So 9% was that picture. I still look at it as the picture. It's 9 out of 100 things. 42%, I still look at the picture. It's 42 out of 100 things, and you can reduce if possible. On the other hand, 0.5% was kind of problematic. Somebody up here came up with 0.5% is 0.005. Okay. Let's try taking 1/2 and dividing it by 100. You weren't having any problem with that idea until I wrote this kind of random one, right? On my calculator, I could do it as a fraction key. A 0.5% divided by 100. See how I typed that in? 1 fraction 2 divided by 100. It's telling me 1/200. So on my calculator, that's 1 ABC 2 divided by 100, and it tells me that it's 1/200th as a fraction. We'd come up with 5 thousandths. Were we right or wrong? Still good, because 5 divided by 5 is 1. 1,000 divided by 5 is 2. Your calculator gave it to you, and always will, always reduced. Yeah?
So what if it's something like 9.2%? Would it still work the same way?
It's a little harder. If we wanted 9.2% and we really felt like writing it as a fraction, I'd recommend just don't worry about it. But to do 9.2% as a I think that you're not too far off. There's a couple of these random ones thrown in your homework. But if I wanted to change 9.2%, I think of it as 9 and 2/10. And I'm going to divide that by 100. And my calculator will do that and say it's 23 out of 250. Are we ever going to use that particular one in the real world? I just don't think so. But if I wanted to convert this to a fraction, I would go 9 ABC to ABC 10, like it was a mixed number, 9 and 2/10, divide by 100. Okay, so I'm going to call that one a challenge problem. It's not that big a deal. The reason the 0.5%, the only one that's like this that I care too much about, it's nice, is that if Ben Bernanke had said that employment or unemployment would be better, if unemployment was going to raise by 0.5%, that would mean that 1 out of 200 people were going to lose their job or something. So that's a good one just to know that 0.5% is 1 out of 200 people. And then finally, and then I'll hand back your exams. Everybody get that written down?
There's like another section that I didn't finish.
Yeah, let me finish up there. So the last one. Last thing you'll be asked to do in 6.1 is change a fraction to a percent. And the trick here is take your fraction and use the divide key to make it into a decimal. And then change that decimal into a percent. So we're going to go through the decimals. And to change the decimal to a percent, that's the one where we move 2 places to the right. I bet a bunch of you know what the fraction 1/2 is as a percent. If half of you do something, it's 50%. And the way that would look as a process is 1 divided by 2 is 0.5 as a decimal. But as a percent, what do I do with that? So it's 0.5 as a decimal. 2 places over, it's 50%. That's really actually a more important one than it sounds. So if they want you to convert three out of 5 people doing something, calculator, what do I type in my calculator? I get 0.6, which is what percent? We'll talk about, and you can try to remind me, I'll try to remember. We need to talk about, there's some rounding that happens when you do some of these, such as if fraction 1/3 you might think about. But I want to give myself enough time to explain your rewrite. Actually, I'll do it on the pen. So let me start by giving everybody the rewrite form. Okay, on the rewrite form here, it says it's due before the March 8th at noon. Okay, if you get it done by Wednesday, it's awesome. I'll totally take them Wednesday, but I gave you more time. So if you don't think you'll get it done by Wednesday, the place you'd have to be is bring it is to my mailbox, which is SSB 316.
It says due before Friday.
At noon.
So it's due before noon?
Yeah, on Friday. So Friday's cool, just right around the noon hour. And actually, I usually leave at 1. You basically just have to beat me out the door. But if I say noon, I teach till noon. So that's...
So where do you teach at?
No, you just bring it to SSB 316 by noon on Friday.
I mean, 159.
Yeah, if you want. Is that clear? Okay. Friday's cool, just by noon. And then the other thing that's important on here is it says somewhere in here that the Learning Center helps okay. Where does it say that?
You may use that.
Okay. And then that's important because if they ask you in the Learning Center, you can point right to that. So the Learning Center can help.
What do you mean if they
Or
ask?
private tutors?
Mm-hmm. What I mean, Trish, is that if you want to ask them a question, they say they can't help you, you can just point to that.
Say they couldn't help you because it was a test?
Exactly.
Okay.
Same page?
Yes.
Okay. And then the other thing is, this is a kicker, you must include a sentence explanation. So I want to, in a separate color on a separate piece of paper, the fixed problem and explain what you fixed. So you got to write it out. And I'm running out of time, but I wanted to spell out that if you got 50%, you could earn up to 75% if you correctly follow all the rules, because you can earn up to half the points mixed up. And we'll talk about that on Wednesday if you want when we talk about percents. If you earn 70%, you could earn up to an 85%.